All right, Math 150, let's talk about graphing exponential functions for a few minutes today. What we want to do is we want to look at when we have an exponential function, first of all, that means you're going to have a number raised to a variable. Okay, that's the main thing we're looking for. Exponential functions fall into this category of a number raised to a variable. What is this graph going to look like? So we're going to take a look at this particular expression. We've got f of x equals 2 to the x. We're going to plot this on the Cartesian coordinate system. And the idea is to get a good understanding of what this graph looks like. And we're really just going to do it by some plotting points to start with. So let's take a look. Let's say that we've got this spread out. Let's call this 1. Let's call this 2, 3, and get our values on here. And then this would be -1, and then -2, and so on. Okay. Well, if we were just to plot these points, when I have an input of 0, f of 0 means 2 to the 0. We all know that's 1. The next one is going to be f of 1, and that's going to be 2 to the first. That's going to be 2. And f of 2 is 2 to the second, which is 4. Well, you can really quickly see we're starting to develop a pattern here. We are doubling the value before us. So at 0, we get a value of 1. All right. Then at 1, we've got an output of 2, so it doubles. Next one, 2, we're going up 4, so that's going to double again. At 3, we're going to go all the way up to 8, so there's 4, 1, 2, 3, 4, 4 more, so we're doubling again. And by the time we get to 4, we're all the way up to 16, and I'm actually off the paper because it's going up so high. Going backwards, we'd have to do f of -1. Well, this is where our negative exponents come into play. We get 1/2. So remember, going this way, we're multiplying by 2. Going this way, we're dividing by 2. So that's actually going to take us down to 1/2. And then when we get to the -2, we're going to actually be at 1/4. We are going to have this type of shape emerging. And what's happening is once this guy, once this expression starts picking up steam, it's going to go up very, very, very quickly. And that is the characteristic of the exponential function that we really want to be aware of. Once it starts increasing, it's like the snowball rolling down the hill. It's going to get big really, really, really quick. So this is the graph of 2 to the x. If we now go down and I ask you to graph 10 to the x, well, I'm going to let you know a little secret. All exponential functions are going to look very much the same. So 10 to the x's graph is going to have that exact same shape. It's going to look just like this. The difference is the labels, okay? The difference is the labels. Now, the y-intercept will still be f of 0, and that will be 10 to the 0, so that's kind of important. We're going to hit that value of 1 again. But this time, every time I move over 1, I'm not doubling. I'm going up tenfold. So this would actually have the value 1, 10. When I move over again, I'm not doubling. No, the base this time is 10. So this is actually going to go 10 times as high. So this is going to be 2 100. The next one, 3, and you can see we're really exploding. It's going to go all the way up. We're going to be at 3 1000 by the time we get to this. So every time I step this way, I am multiplying by 10, which means if we're going this way, we are dividing by 10. So we're going to get small really quick. This is going to go over to -1. This is going to be at 1/10. At -2, we're going to be at 1 100th. You're going to see this get really, really small very quickly. And it's going to lead to the idea of an asymptote. We're definitely going to have a horizontal asymptote as we go this way, because we're never going to equal 0. We're always going to have a little fraction left, but it's always going to be 1 over 10, and then 1 over 100, 1 over 1000. And you can see we're always going to have some little part of this fraction left, but it's getting closer and closer and closer to 0 the entire time. So again, these two shapes actually are the same. The only difference is the scaling of it, okay, the scaling of it. So let's go down, let's look at one more here today. Let's look at this example. We're going to put in x and the y-axis. And this time we're going to do f of x is equal to 3 plus 4 to the -x. So on this one, what I'm going to do is remind you of your transformations. Let's really look at what happens when we do g of x equals 4 to the negative x first. And then we'll take care of that 3. Because you should remember, that's just going to lift us up by 3. Well, 4 to the negative x, again, we're just going to start thinking about points. What's the y-intercept? Well, we're going to do g of 0. But notice the negative exponent doesn't do anything because it's 0, and negative 0 and 0 are the same. So we're still going to end up with 4 to the 0, and that's going to be 1. Okay, so we're still ending up in the exact same place. We're ending up right there with a value of 1 and 0. Now, what's happening is all the positive inputs are going to be forced to act like negatives because of that negative right there. So when I do g of 1, I'm really doing 4 to the negative 1, which is 1/4. When I do g of 2, I'm getting 4 to the negative 2, which is 1/16. Likewise, when I go to the negative exponents and I do g of negative 1, it's 4 to the negative 1. Well, that's 4 to the first. G to the negative 2 ends up being 4 to the negative 2. That's 4 squared. That's 16. So what we're finding out this time is going this way, we are dividing by 4, and going this way, we are multiplying times 4. It's actually going to have a reverse effect of what we saw before. So as we go back, I'm going to call this one negative 1. I've got to go up 4 times higher than my value of 1 at the y-intercept. So 1, 2, 3, 4, it's going to be there. When I go back to negative 2, I've got to be 4 times higher than this guy, which is 4. That's going to take me all the way up to 16. That's going to be off the chart. It's already going to be off the chart here. So now as we move to the right and we go to positive 1, that's going to be my 1/4 value. When I go to positive 2, that's going to be 1/16. When I go to positive 3, that's going to be 1/64. You can see that we're going to get a horizontal asymptote, and then it's going to just shoot up like this. And that's what we're going to end up with for this graph. That is g of x equals 4 to the negative x. I asked to do 3 plus 4 to the negative x. So what that's going to do is it's going to duplicate that graph. It's going to duplicate that exact graph, but it's going to move it up 1, 2, 3. It's going to move it up just to there. So it's going to take that exact same shape and move it up. So the second graph we just did is f of x equals 3 plus 4 to the negative x. The first graph we did was g of x equals 4 to the negative x. If we subtracted from it, that transformation would behave in the opposite direction. It would actually move it down. So this could be something like h of x equals 4 to the negative x minus 5, something like that, okay, because we just move it down. So real basic introduction to graphing exponential functions. I'll have some more for you later on this weekend. Hope that makes sense. Talk to you all soon.